topic for this group project is drug abuse for female. This is our group member Nur Farah, Suziana, Fernandawanda, and Nurul Najwa. Drug abuse has become a global issue of concern. It affects not only individual users but also their families and communities. Drug abuse is a serious public health issue that affects individuals across all ages, genders, and backgrounds. However, when it comes to female, the challenges and consequences of drug abuse can be particularly complex and far-reaching. Women may experience addiction differently than men, often influenced by biological, psychological, social, and cultural factors. From the risk of developing dependence more quickly to the unique stigma and barrier they face in seeking help, the impact of substance abuse of female requires targeted attention and understanding. Addressing drug abuse among women is not just about treatment. It's about prevention, education, creating supportive environment that empower them to lead healthy, drug-free lives. The data below contains the year of 2002 until 2011 of data for drugs abuse for female. For this group project, we only use quadratic equation model.
Hi, I'm Suziana Laistani. Okay, let's start with the quadratic model. A quadratic model describes a relationship between variables in the form of parabola. The general equation is y ax squared plus bx plus c. Here is the output of dependent variable, is the input of independent variable, and constant that shapes the curve. This model is useful when the relationship isn't a straight line. For example, when you are analyzing motions, growth or cost over time that increase or decrease at an increasing rate, especially when we decide to use drug abuse where it shows the growth where the graph. Now, to fit any curve or line to data, including a quadratic one, we want to find the best value for the coefficients, and to do this, we can use something called the normal equations, which comes from linear algebra. The normal equations help us solve for the best fit parameters without needing to guess or iterate. In this formula is the design matrix containing your input data is the output of target variable, which the data is the vector of coefficients we want to find. We multiply, transpose, and invert matrices to solve for which gives us the best fitting equations based on the data. So to summarize, the quadratic model helps us describe curve trends in data. Meanwhile, the normal equation is a formula that lets us calculate the best coefficient for our model. And together, they allow us to fit a smooth, accurate curve to data useful in science, business, and engineering.
Thank you, Suzy, and Assalamualaikum and hi, my name is Nur Najwa Natasha. On this slide, we are looking at the least square solution to a system of equation. This method helps us find the best fit solution when a system doesn't have an exact solution, particularly useful in data fitting. Here, we have matrix A and the product A transpose A. These are used in the formula. Open bracket A transpose A, close bracket V equal to A transpose B. This formula computes the vector V, which contains the coefficient of the best fit quadratic curve. As shown here, after performing the necessary matrix operation, we obtain the solution vector. This gives us the equation of the best fit quadratic curve, y equal to 12.698 plus 1.1030x minus 0.0731 x squared. Now that we have determined the best fit quadratic curve, we move on to evaluating how well the curve fitted data using the error vector. On the left, we have matrix Y, which contains the original Y value from our data. Next to it is a NV, the predicted Y value obtained by multiplying the matrix M with the coefficient vector V. The difference between Y and NV gives us the error vector. This value shows how far off our prediction. are from the equal value. To quantify the total error, we calculate the magnitude of the error vector. This is formula magnitude of error vector. After compute, we get magnitude equal to 1.2912. Thank you, Najwa. Hi and Assalamualaikum. My name is Nafara. Now let's take a look at the graph of the best fit graph for our quadratic model. On this slide, we can see the scatter plot of the data points represented by the blue dots. These points were obtained from our observation or dataset. The red curve in the graph is the quadratic best fit graph. It was generated using a regression model to closely follow the trend of the data. As you can see, the curve rises at first, reaches at peak and then slightly curves downward. This pattern indicates a parabolic shape which is typical for a quadratic relationship. This model helps us understand how the variables are related and allows us to predict values within the range of the data. It also gives us insight into where the maximum point occurs, which is useful for interpretation depending on the context of the study. The visual makes it clear that a quadratic model is suitable for fitting this data compared to a straight line which would not capture the curvature. So next is the conclusion. Based on data, it may reflect how HIV cases or substance abuse increase initially, possible to rising drug injection practice and later began to decline, potentially as a result of the intervention strategies such as harm reduction, program, education and awareness campaigns, expanded access to antiretroviral therapy, and government policy shift toward treating drug addiction as a healthy issue. The peak of the curve around the mid-range of the x-axis may represent the point where the crisis was at its worst before effective public health measures start to reduce the prevalence. On the article, this graph might tell us on how Malaysian efforts in addressing drug abuse that link to HIV transmission have evolved over time. It shows that with some strong policy, medical intervention and community support, the tide of dual epidemic can be turned. From the data analysis, the graph is represented as quadratic model.